Have you ever wondered how a missile works? These fascinating feats of engineering are integral to modern warfare and space exploration alike. A missile, simply put, is a guided weapon system. It's designed to deliver a payload, often a warhead, from point A to point B with remarkable precision. Missiles aren't just for warfare, though. They're also the backbone of our ventures into space, launching satellites and astronauts into the cosmos. There's a rich variety of missiles, each with its own unique characteristics. Ballistic missiles, for instance, follow a curved trajectory, soaring high into the atmosphere before plunging back down onto their targets. Cruise missiles, on the other hand, skim the Earth's surface, using advanced navigation systems to find their way. Each type of missile is a testament to human ingenuity, solving complex problems of physics, engineering, and navigation. Now that we know what a missile is, let's delve into how they actually work. A missile, although complex, can be broken down into 4 basic components. These are the warhead, the propulsion system, the guidance system, and the control system. Each of these components plays a crucial role in the overall function and success of the missile. First up, the warhead. This is essentially the business end of the missile. Its main purpose is to deliver the destructive force to the target. Warheads can contain a variety of destructive materials such as explosives, chemical or biological agents, or even nuclear materials. The key here is that the warhead must be able to withstand the stresses of launch and flight, and still function correctly upon reaching the target. Next, we have the propulsion system. This is what gives the missile its speed and range. It's composed of rocket motors that burn fuel to generate thrust. The propulsion system determines the speed at which the missile will travel and how far it can go. It's also responsible for getting the missile off the ground and into the air. Then we have the guidance system. This is like the missile's onboard GPS. It's what steers the missile towards its target. The guidance system could be using a variety of methods to achieve this, such as radar, laser guidance, or satellite navigation. Regardless of the method used, the goal is the same: to ensure the missile reaches its intended target. Finally, we have the control system. Think of it as the missile's autopilot. It's the brains of the operation. The control system takes information from the guidance system and uses it to adjust the missile's flight path. It can change the direction, altitude, and speed of the missile, ensuring it stays on course. So there you have it, the 4 basic components of a missile. The warhead delivers the destructive force. The propulsion system provides the speed and range. The guidance system steers the missile towards its target, and the control system adjusts the flight path based on the information from the guidance system. These components work in harmony to enable the missile to reach its target. And that's the beauty of the science behind missiles. The journey of a missile begins with its launch. At its heart, the launch phase is all about overcoming gravity. The missile's propulsion system plays a critical role here. This system, often powered by solid or liquid propellants, is responsible for generating the necessary thrust. Think of thrust as a force, a push so powerful that it lifts the missile off the ground and propels it into the air, defying the pull of gravity. In the case of solid propellants, the fuel and oxidizer are mixed together into a solid composite. Upon ignition, a fierce reaction occurs, producing hot gases that escape through the nozzle, propelling the missile upwards. On the other hand, liquid propellants consist of a separate fuel and oxidizer. When these 2 components combine and ignite, they too generate hot gases that provide the thrust. However, liquid propulsion systems offer an added advantage. They can be throttled, stopped, and restarted, providing greater control during the launch phase. The propulsion system doesn't work alone, though. It works in tandem with the missile's aerodynamic design. The shape, the fins, the nose cone all contribute towards reducing air resistance, allowing the missile to slice through the air with minimal friction. Once the missile is in the air, the guidance and control systems take over. It's the start of a new phase, where the missile's course is carefully managed to ensure it reaches its intended target. But that's a story for another scene. After launch, the missile enters the flight phase. This is where the real magic happens, where the intricate dance of technology and physics propels the missile towards its target. The flight phase is all about maintaining the correct trajectory and making necessary adjustments along the way. This is where the guidance and control systems truly shine. These systems serve as the missile's brain and the steering wheel, keeping it on the right path and making corrections as required. Imagine you're on a road trip. You've set off from your starting point, and now you're on the open road. You've got your GPS system guiding you, and you're making slight adjustments to your steering, speed, or route as necessary to stay on course. That's essentially what the missile is doing during the flight phase, but on a much more complex and high-tech scale. The guidance system uses a variety of techniques to keep the missile on track. Some missiles use inertial guidance, relying on gyroscopes and accelerometers to measure changes in direction and speed. Others use terrain comparison guidance, comparing the ground below to a preloaded map to determine its location. Still, others might use celestial or GPS guidance, looking to the stars or satellites to find their way. Then there's the control system. This is what physically moves the missile, adjusting its fins or thrust to change direction or speed. The control system takes the information from the guidance system and translates it into physical movements. It's like the hands on the steering wheel, turning the car based on the directions from the GPS. But it's not a simple case of set and forget. The guidance and control systems are constantly communicating, constantly adjusting. They're taking in new data, responding to changes in the environment, and making millisecond decisions to keep the missile on its predetermined path. With the target in sight, the missile prepares for the final phase, the terminal phase. As our journey continues, we'll see how the missile makes its final approach and delivers its payload. But for now, we've gained a deeper understanding of the intricate ballet that is the flight phase of a missile's journey. The terminal phase is the final and most critical part of a missile's journey. This is the point at which all the systems we've discussed so far must work in perfect harmony to ensure mission success. As the missile nears its target, precision becomes paramount. The guidance system, incorporating data from various sensors, adjusts the missile's path to zero in on the target. Let's dive a little deeper into this. Imagine the missile is a dart player's hand, and the target is the bullseye. The dart player doesn't just throw the dart and hope it hits. They use their eyes to judge the distance, angle, and force needed. The same principle applies to the missile. Its sensors are its eyes, feeding information back to the guidance system. This system then makes necessary adjustments to the missile's trajectory, ensuring it stays on course. Now, what happens when the missile reaches its target? This is where the warhead comes into play. The warhead is essentially the payload of the missile, the part that carries out the intended effect, be it destruction, disruption, or dissemination of information. Depending on the specific type of missile, the warhead may be triggered by impact, proximity, or even timed detonation. So, as the missile approaches and strikes its target, the warhead is triggered, delivering its payload and completing the missile's mission. This final act is the culmination of a complex dance of technology and physics. And that, in essence, is how a missile completes its mission. So, we've taken a journey from launch to impact, but what are the key points to remember about how a missile works? Firstly, a missile is not just a simple tube filled with explosives. It's a complex piece of engineering, designed to deliver a payload to a specific target, often over great distances. It consists of several key components, each playing a critical role in its operation. The propulsion system provides the power for the missile to reach its target. It works in tandem with the guidance system, which ensures the missile stays on the correct trajectory. The warhead, the destructive part of the missile, is designed to cause the desired effect upon reaching the target, be it a simple explosion or the release of a more complex payload. The other components, such as the airframe and flight control systems, provide the structural integrity and maneuverability necessary for the journey. The journey of a missile is broken down into 3 phases: launch, flight, and terminal. Each phase presents its own unique challenges and requires specific systems to overcome them. The launch phase is the start of the journey. This is when the missile is propelled from its launch platform, be it a silo, a ship, or an aircraft. It requires a significant amount of energy and precision to get the missile off the ground and on the correct trajectory. The flight phase is the longest part of the journey. This is when the missile is traveling towards its target. The guidance system is critical during this phase, as it must continuously adjust the missile's trajectory to ensure it hits the target. The terminal phase is the end of the journey. This is when the missile reaches its target and delivers its payload. Precision is key in this phase, as a miss by even a few meters can drastically reduce the effectiveness of the payload. Next time you hear about a missile launch, you'll know exactly what's happening every step of the way.